Without reinforcement, the human brain deletes roughly 50 to 70% of any newly learned information within the first 24 hours. You sit through a lecture, you close your laptop, and the decay begins immediately. To stop that decay, we usually default to reading our notes over and over, or highlighting a textbook. These passive methods create what cognitive scientists call the illusion of fluency. Because the text looks familiar on the page, your brain tricks you into thinking you've actually memorized it. It feels highly productive in the moment. This is the Ebbinghaus forgetting curve. After a single cramming session, retention plunges toward zero. But if you recall the information at specific intervals using spaced repetition, the curve changes. Retention drops slightly, then bounces higher with each review, eventually flattening near total retention. That initial drop is important. The mental struggle required to recall a fading memory is exactly what signals your brain to keep it. Feeling comfortable and productive during a study session is usually a sign that you aren't building long-term memory at all. Researchers refer to that necessary friction as a desirable difficulty. For your brain to encode a memory, the practice has to feel a little bit hard. Normally, we drill one topic repeatedly. This blocked practice lines everything in a rigid row, creating a temporary sense of mastery. But with interleaved practice, the system mixes completely different topics. Switching mental gears drops immediate performance, but significantly boosts test scores weeks later. Because doing this manually takes too much effort, students rely on flashcard apps to automate the spacing and the mixing. But these apps are not built the same way. The most popular study platforms use vastly different underlying algorithms. Some use rigid box systems. Others use continuous mathematical formulas to calculate when you forget. The code dictates the friction. If you pick software that doesn't match your specific study timeline, you are either going to suffer intense academic burnout or walk into your exam with a false sense of security. For medical students, law students, and language learners, memorizing thousands of data points, Anki is the default tool. It is built for high-stakes optimizers. The initial setup requires high effort. The interface is technical, and you have to understand terms like ease factors and retention rates just to configure your daily reviews. Anki runs your answered card through algorithms like SM2, outputting precise routing paths like 1, 4, or 12 days into the future. The system tracks thousands of cards, projecting optimal intervals across months and years to ensure massive datasets stay in your memory. But this requires unbroken daily discipline. The algorithm assumes you will study every single day without exception. If you take a weekend off, the algorithm doesn't pause. Those due cards pile up, creating an overwhelming backlog that takes hours to clear. While the desktop version is free, the iOS mobile app carries a $25 upfront cost, a notable financial barrier compared to other options. Anki forces you to trade extreme daily behavioral friction and a steep learning curve for the mathematical guarantee that you will retain the knowledge. For many students sitting through hours of lectures, the main barrier isn't reviewing the flashcards. It's the sheer amount of time required to type them all out. Platforms like RemNote and Mindomax operate as ecosystem solutions to eliminate that duplicate effort. This requires moving your entire workflow into a unified workspace. You take heavily formatted lecture notes on the left, and the software automatically generates cleanly formatted flashcards on the right. By using specific text markups or integrated AI features, these platforms can extract study cards directly from raw PDFs and lecture audio files without you having to copy and paste. These tools remove the administrative friction of card creation. They shift your energy away from formatting data, reserving it entirely for active recall. Then are the short-term survivors. If you have an exam on Friday, you have zero tolerance for configuring software settings or learning text markups. This diagram shows the original Lightner system, which drives many of the simpler apps. It uses fixed levels. Get a card right, it moves to box 2. Get it wrong, it drops all the way back to box 1. It's a rigid physical sorting method. Quizlet uses a similar proprietary system that categorizes cards into know and still learning piles. Neither of these approaches utilizes continuous, long-term mathematical spacing. You sacrifice precise algorithm-driven retention in exchange for immediate, frictionless study sessions. This connects to cognitive load theory. Extraneous load is the mental energy you waste on things outside of learning, like navigating cluttered interfaces, dismissing paywall pop-ups, or manually sorting your cards. In this diagram, you can see working memory capacity represented as a battery. High extraneous load from UI clutter or complex setups drains the battery rapidly. It leaves almost zero power for germane load, the actual mental effort required to encode a memory. Baseline systems eliminate extraneous load, letting you start studying immediately. That makes them excellent for passing a Friday test, but their lack of deep algorithmic spacing makes them incapable of supporting high-volume, long-term mastery. There is no universal best flashcard app. There is only the app that matches your specific timeline and constraints. This decision tree maps out the options based on your ultimate goal and your tolerance for setup friction. If your objective is long-term mastery for a medical board or a fluency exam, the path points to Anki. You have to accept its steep learning curve and daily scheduling demands. That is the necessary cost for gaining total control over the algorithm. If you take heavy lecture notes and need workflow optimization, the path leads to RemNote or Mindamax. You consolidate your tools and let AI handle the formatting. And if your goal is imminent test survival, you follow the path to Quizlet or a dedicated Lightnerbox app. You bypass the complex math for a fast, frictionless study session. The right choice comes down to picking the software whose inherent friction aligns with the deadline on your calendar. The data reveals a very clear reality check. The specific mathematical algorithm running in the background matters far less than your daily consistency in actually opening the app. Whether you use a complex SM2 algorithm or a simple 5-box system, you still have to embrace the desirable difficulty. You have to actively recall the information and interleave your topics to force your brain to work. Mastering how you learn is not about finding an app that eliminates the struggle. It is about choosing the struggle that yields the best return for your specific goal.